Hi guys, welcome back again. Here we are, 1.2. This is about the fifth time I'm having to record this because I keep getting like interruptions or sounds or make like a silly error or something. Anyways, let's hope this one goes well. Yeah, let's jump into it. Number four. Number four, graph the equation by plotting points and find the intercepts of the graph. Okay, this type is actually very simple because plotting points is kind of like our easiest method for graphing, right? If you don't know what the thing looks like, have no clue, you can always resort to just plotting points. Now, actually though, you might have recognized this. This is a special format that we've seen before. This is actually the equation for a semicircle. And the negative here means it's going to end up being on the bottom side. But if you don't recognize that, it's okay. It's okay because we're about to find that out by plotting points, right? Now, when I look at this thing, and let me just reiterate what this is. This is negative the square root of 9 minus x squared. When I look at this thing, my first thought is, okay, what's going to make this all turn out to be a nice number? What's going to make this calculation easy? The most obvious choice to me is if x is 3, when I square 3, I get 9. 9 minus 9 is 0. Then I take the square root of 0, I get 0. And the negative of 0 is still 0. So if I plug in 3, I'm going to get 0. And now because this is squared, if I plug in negative 3, I'm still going to get the same result, also 0. So those are two easy points right away. The other easy point, usually I always look for 0 or 1 if those are easy. In this case, 0 would be a nice point. 1, not as much because I have 9 minus 1 would be 8, and square root of 8 is not a nice number. But a 0 for sure, because if it's 0, 9 minus 0 is 9. Square root of 9 is 3, and then a negative of that would be negative 3. So plug in 0, and I got negative 3. So I got those 3 points. Let's plot them on a graph, see what happens. I discovered recently that after all this time working with drawing pad, that I didn't know that it actually straightens my pencil lines. I thought it only straightened pen lines for some reason, but it does for pencils too. And I like going with the pencil. I feel like it looks a little nicer. So anyways, I'm just talking to myself here. 3, 0 would be right here. 1, 2, 3, 0. Negative 3 would be 0 would be negative 1, 2, 3, 0. And 0, negative 3 would be 0, negative 1, 2, 3. Right there, something like that, right? And then connecting those dots, we see, oh yeah, it is a semicircle actually. If I can draw a semicircle, I can't really. I wonder if I have better luck with pencil. I feel like that looks slightly better. I don't know. Anyways, that's the graph. Yeah, sketch the graph. Now we got to find the intercepts of the graph, but that's actually easy. Just looking at it by inspection, I can tell already. Right, x-intercept right there and there. Y-intercept right there. Now let's say you didn't know that. Then how do you normally find intercepts? You just plug in the opposite one for 0, right? So if I want x-intercepts, then I want y equal to 0. So I plug in y equal to 0, what happens? I get 3 or negative 3. So those are my two x-intercepts, 3, 0, and negative 3, 0. Okay, what about y-intercepts? So y-intercepts is when x is 0. Remember, it's kind of opposite, right? So if x is 0, I get negative 3. 0, negative 3 is my y-intercept. Sweet. And just like that, question 4 is done. Okay, question 5 now. Question 5. My personally, probably my least favorite of this bunch of questions. It's not a terrible question, but my least favorite. That doesn't mean I don't know. I wouldn't probably ask that exact question, but you still do need to know about origin, x-axis, y-axis symmetries. You might see that in the form of even and odd questions later that come up later in the section. Anyways, I'm just talking to myself now. Let's answer the question. So looking at this question, one thing I note here, odd power. So right away, my math radar is telling me this is going to be an odd equation. An odd equation means it's got symmetry over the origin. Now, it might have other types of symmetry as well, though, so we still got to check. And how do you check? Let's do one by one. So x-axis, y-axis, and origin. So those are the 3 types we're checking, right? How do we check them? So for x-axis symmetry, what you do is you replace x with negative x. And if you do that, oh, I'm sorry. Backtrack, guys. I'm saying this wrong. For x-axis symmetry, remember it's kind of always backwards, right? X-axis symmetry, I replace y with negative y and see if it turns out the same. If it does, I have x-axis symmetry. Now, y-axis symmetry is also like backwards, right? So y-axis symmetry, I'm going to replace x with negative x and see if it pops out the same. Now, why does that happen? Why am I doing that? Well, think about this with me. X-axis symmetry means if I have a graph here and I reflect it over the x-axis, I get the same thing. So like if I have a graph that's like this, if I reflect it and lands back on itself, it's got x-axis symmetry. So what did I do here though? I took the y value, I made it opposite, and I ended up back where I was, right? So that's replacing y with negative y. You see that? It's kind of a similar idea to how when you check the intercepts, you'd always check for the opposite variable being 0, right? Okay, same thing with y-axis symmetry. Y-axis symmetry, that means you have a graph like this, right? Where if I reflect over the y-axis, I land back to myself. But what did you do there? You took an x value, you replaced it with its opposite, it's negative, and you ended up back where you were. So that's the intuition behind why we're doing what we're doing. Now, for origin symmetry, you actually do both of those things. You exchange x with negative x, and you exchange y with negative y, and if it comes out to the same as the original, then you give it origin symmetry. I should have used color coordination here, so let's do that. Let's change it to blue. Okay, but we're gonna work in pencil because that's my favorite, and I think it looks the best. So x-axis symmetry, my original equation is y equals to negative 3x to the 5th plus 2x to the 3rd. I'm going to change y for negative y. And then I'm going to solve this thing for y to see if it pops out the same. Solve for y. I got to take everything negative, right? Negative times, this time negative 1. And then this whole right side of the equation times negative 1. So that's going to be 3x to the 5th minus 2x to the 3rd. Comparing to my original, they don't match. They don't match. So no x-axis symmetry. Sim for short. Okay, now what about y-axis symmetry? So I'm going to start with my original equation. Y equals to negative 3x to the 5th plus 2x third. This time I'm changing x with negative x. So negative 3, negative x to the 5th plus 2, negative x to the 3rd. That's y is equal to, now when you take a negative to an odd power, you end up getting a negative, right? So it's going to be negative x to the 5th. And the difference here is this time, the x to the 5th happens first, and then it's negative. In this case, it was negative x times another negative x times another negative x times another negative x, right? Okay, this one, 2, and this is negative x to the 3rd. Okay, so now negative times negative is going to be positive. That's 3x to the 5th. Positive times negative is negative. That's negative 2x to the 3rd. And looking at these things, they do not match up. No, okay, no matching. So no y-axis symmetry. All right. So now the origin. Origin, remember we exchanged both. So originally we had y is equal to negative 3x to the 5th plus 2x to the 3rd. Now we're going to change it to negative y is negative 3, negative x, oops, sorry, wrong spot. Negative x to the 5th plus 2 negative x to the 3rd. That's going to give me negative y is equal to 3x. I'm just going to skip a step here and go to the result. This is positive 3x to the 5th. It's going to be negative 2x to the 3rd. And I've got negative on this side. Gonna multiply both sides by negative 1. I'm gonna get positive y is negative 3x to the 5th plus 2 x to the 3rd. And looking at that thing, here's my end result. Here's my starting position, and they're exactly the same. And since they're exactly the same, that means yes, origin symmetry. Origin symmetry, remember, just remind you visually, that means if I take my graph and I rotate it 180 degrees, it lands back on itself. Okay. Next question. All right. Sorry, it's taking me a while to erase this thing. Let's go, come on. Okay, number 4, 5 done, number 6 now. Determine the center radius of the circle in the sketch. All right, no problem. Got x squared plus y squared minus 4x equals 2y plus 11. So when I see a question like this, first thing I want to do is get my equation to be the standard form for a circle. I'm going to do that by gathering my x's together and leave a little blank here. So I'm going to need some space to complete that square. Plus y squared, and then here I've got 2y on the right side of the equation, but I'm going to pull it over to the left by subtracting on both sides. Again, leave a little space, and then leave that 11 untouched on the right side. Okay, so now I gotta figure, what do I add to make this thing a perfect square? Well, that's divide that by 2, which is 2, and then square it, which is 4. So I'm adding 4. Same thing here. Divide that middle term by 2, I get 1. Square 1, I get 1. So I add 1. And if I did it to the left, I should do it to the right. So I added 4 and I added 1, right? Like that. Okay, now this thing turns out to be a perfect square now, though I specifically chose this number so that this would end up being x minus 2 squared. And if you don't believe me, you can just FOIL this thing out to check, but it's always, this term turns out to be half of that guy right there. And this term here is going to be y minus 1 squared. So this term is always that guy in half, or another way to look at it is it's square root of that. Square root of 1 is 1, right? Square root of 4 is 2. And you can check both those things. Both those things should match up. This was a plus because this was a plus. On the right side, I got 11 plus 4 is 15 plus 1 is 16. 16, that's great news because square root of 16 is 4. And now, of course, it's going to be that way because they asked us to sketch the graph. So they're going to give us a nice number where I get a nice whole number. It's easy to sketch. At least that's, they're not going to, I guess I shouldn't say they wouldn't because sometimes they might, but that would be mean. Okay, so now we got to determine the center and radius. Center radius actually easy. I don't know if you guys remember this, but there's this standard form, which is x minus h squared plus y minus k squared is equal to r squared. That's the standard form. Where this h is the center for the x value, this k is the y value for the center, and then r was the radius, right? So that means our center is already set up, easy to see. It's 2, 1. And what about the radius? Well, that's what I said a moment ago, right? I got 16 is r squared, so the radius is going to be the square root of that, which is just 4. So center at 2, 1, and I got a radius of 4. So 2, 1 means 1, 2. 1 right there. Radius of 4. So 1, 2, 3, 4 to the right. 1, 2, 3, 4 to the left. 1, 2, 3, 4 up. And 1, 2, 3, 4 down. Oh, you're probably so irritated watching this. Yeah, it's so slow. If I was you, I'd definitely be watching this at double speed. Okay, there we go. Something like that, it doesn't line up exactly because I'm not measuring with a ruler, but that's the idea, right? It only is set to sketch, so it's pretty close. Okay, one more for this section. Number 7, write the standard equation for the circle with center -2, -4, passing through the point 1, 1. No problem. Okay, right away I see -2, -4, but remember the standard form, let's just remind ourselves where I wrote a moment ago. Let's remind ourselves. X minus h squared plus y minus k squared equals r squared. So notice this is a minus there, right? That means if I have a negative center, negative values for center, then it's gonna be reversed. So that means when I write my equation is gonna look something like this: 8x plus 2 squared plus y plus 4 squared is equal to r squared. Now the only missing piece is the r. I don't know what r is, but what is r? R is the radius, right? It's the distance from the center to any point in the outside of the circle. Okay, but I know if my circle is passing through some point 1, 1, and I know the center, I just need to find the distance between those two things. So r is really just equal to the distance between those two things, -2, -4, and 1, 1. And this is something we did back in the previous section, didn't we? Yeah, I just finished doing a whole bunch of these. So this is actually a very nice kind of question where you can combine a couple of different sections in one. Not saying I for sure will do that, but that would be a nice thing to do. Okay, what's the distance formula? It's the square root differences between the x values, which is -2 minus 1 squared, plus differences in the y values, -4 minus 1 squared. Square root of -2 minus 1 is -3. And then -4 minus 1 is -5. So I've got square root of 9 plus 25, which is the square root of 34. All right, so r is the square root of 34, right? That means when I square r, I get 34. So now we're ready to complete this thing. Let's write it in pencil again. So the final result, x plus 2 squared plus y plus 4 squared. Sorry, I don't know what happened there. Squared is equal to 34. That's it. This is my answer right there. All right, just like that, guys, we're done with section 1.2 at last.